Okay, so in this video we're going to be going over the day 4 warm-up. We've got 3 questions here, one about constant acceleration, and then 2 questions about free fall. Okay, so let's take a look at question 1. And as always, let's see if you can answer this question on your own. It's a pretty straightforward constant acceleration question, so hopefully you can figure this out on your own. Okay, so question 1 says a car in front of the school goes from rest to 27 meters per second in 3 seconds. What is its acceleration, assuming it is constant? Okay, so we know that we've got these 3 equations if we have constant acceleration. And as you read through, you're looking, number one, for numbers and units, of course, but also for context clues like if the car starts from rest, that means it has an initial velocity of 0. Okay, that's its starting velocity. Its ending velocity, its final velocity, v final, is going to be 27. And the time is 3 seconds. Now, the unknown in this question is acceleration. And so we've got 3 givens and 1 unknown, just like a normal constant acceleration problem. You write down your equation. Okay, now how do I know which equation to use? Well, just because this is the only equation that has these exact 4 variables. Okay, Vf equals Vi plus A times T. You plug into the equation, 27 for V final, V initial is 0, plus A, which is unknown, so I leave that in there, times 3. You simplify. Okay, now normally I would subtract right here, but the 0 is not going to do anything even if I subtract it from both sides, so I'm just going to ignore that, and I basically have 27 equals A times 3. The 3 is multiplying the A, and so I have to do the opposite of multiplication, which is division. I divide both sides by 3 to get rid of that 3, and I get A equals 9 meters per second squared. Okay, so that is the answer for question number 1. Okay, very straightforward type of question. Okay, and by the way, in case you're into cars, if you've ever heard about really fast cars, or you hear something like, oh, this car can go from like 0 to 60 in 4 seconds or whatever. When people say a car can go from 0 to 60 in this many seconds, they were basically talking about acceleration. Okay, just like in this problem, we have, from rest, okay, that's 0, to some like final velocity in some number of seconds. Okay, so if you drive a car that can go from 0 to 60 in like 5 seconds, then theoretically you could calculate the acceleration. It wouldn't be in these units because most cars in this country are in miles per hour and not meters per second. But still, okay, so that is question number 1. Pause it there if you need to look at that. So question number 2, let's take a look. We've got 2 freefall questions. The first question says, Timmy stands at the top of a deep well. He drops a rock into the well. Right off the bat, I'm looking at that and realizing, hey, that is a context clue. Remember, when you drop something, unless you throw it down, if you just drop something, you assume that it starts with an initial velocity of 0. Okay, because before it leaves your hand, it's not moving. And let's see, he determines it takes the rock 2.6 seconds, that's time, to reach the bottom of the well. How deep is the well? Okay, so questions about how high or how deep or how far are always questions about displacement. Okay, so we're looking for dy essentially. Okay, now you can argue whether or not, how deep should the answer be, positive or negative. It doesn't really matter as long as you do it correctly. Now, remember, in a free fall problem, when an object is falling under the effects of only gravity, the acceleration, g, little g, due to gravity, that we use on Earth is negative 10 meters per second squared. Now, if you go to different planets, it would be different. For example, on Jupiter, it'd be like negative 16. Gravity is stronger on Jupiter. On the Moon, it would be like negative 1.6 or something like that. There's not a lot of gravity on the Moon. Okay, but on Earth we use g equals negative 10 meters per second squared. So I want the equation that has g, t, vi, and dy. And that is the equation that looks like this. dy equals vi times t plus 1/2 gt squared. I'm solving for dy, and so I just plug into my equation. dy equals 0 times t, which is 2.6, plus 1/2 times negative 10 times 2.6 squared. Okay. Now, make sure you don't make this common math mistake. Remember, 0 times 2.6 is 0. Okay, and so this 2.6 is basically gone. Okay, it doesn't matter at all. So I'm just going to simplify a little bit. 0 times 2.6 is 0. And so I would have 0 plus this number over here. I'm not even going to write the 0 because it doesn't really matter. And then 1/2 and negative 10 make negative 5. Okay, so I basically have negative 5 times 2.6 squared. Please do not forget to square the time. A lot of people have been making that mistake as well. Okay, so I'm going to do 2.6 squared first because you always do exponents first. Remember PEMDAS. Times negative 5, and I get dy equals negative 33.8 meters. Now, does that answer the question, how deep is a well? Well, kind of. I mean, basically what that means is the rock fell down 33.8 meters. Now, can depth be negative? Can height be negative? Not really. And so maybe I would answer this question probably with a positive. If somebody asks you like, oh, how deep is your well on your property? You probably wouldn't tell them a negative answer. And so, I would take either of these. If you just do the calculation and you don't try to answer the question, you'd probably end up with a negative. But really, the answer to this question should probably be positive. Okay, so pause it there if you need to look at that. And let's take a look at one more quick freefall question. Question number 3 says a tennis ball launcher shoots a ball straight upwards with an initial velocity of 30 meters per second. Okay, so initial velocity, that's obviously vi because it tells us it's initial velocity. What will the velocity be? So they're asking us about a velocity. They already gave us the initial velocity, so that means the velocity they gave it, or they're asking for, has to be v final. Make this a little darker. And they give us 4.0 seconds, and so that's time. So that means that I want to use the equation that has v final, v initial, t, and g. Remember, g is the acceleration due to gravity. Okay, so here's my equation. I'm looking for v final. V initial is 30 plus negative 10 times t. Now remember, you cannot combine these because they're not like terms. You cannot add 30 and negative 10 to get 20. That's not how algebra works. Okay, you cannot add apples and oranges. Okay, so if I want to get, oh, and I don't know why I forgot to plug in for time. Sorry about that. So time is 4.0 seconds. And so now I'm just going to simplify, and I'll finish the problem up here just so I have space. Okay, v final equals 30 plus negative 10 times 4 is negative 40. And 30 plus negative 40 equals negative 10 meters per second. Now, that is the answer to the question, and that is correct. And now at this point, you could ask yourself a question, and it would be a very good question. If the tennis ball launcher shoots the ball up, why is the final velocity negative? That doesn't make any sense. Well, here's the answer. What's going to happen after the tennis ball reaches its maximum height is it's going to stop, and then, guess what? It's going to fall back down. Okay, so after 4 seconds have passed, the tennis ball has reached its maximum height and is currently falling down. That's why it makes sense for the tennis ball to now have a negative velocity. Now, if I wanted to, I could give you a question asking you, like, how long does it take the tennis ball to reach maximum height? And just without working at the problem, I'll tell you, just looking at these numbers, you can, check me on your own. But just looking at these numbers, the tennis ball would basically take 3 seconds to reach its maximum height. Okay, so after 4 seconds have passed, it's already reached its maximum height, and now it's been falling down for 1 second. That's why it has a negative velocity, a velocity of negative 10 meters per second. Okay, so that's just kind of explaining why the answer makes sense. So hopefully you feel a little bit more comfortable with free fall problems after that. As always, please let me know if you have any questions, and I will see you guys in the next video.